We need to find the complement of the following expression. The one that we're going to be looking at in this video is part D. In the previous videos, linked below the like button in the playlist right before this one, we did A and B together in a video, and then we also did C in its separate video. So just like part C, we're going to write out part D. So it's like this, and then we have a not operator over all of them. So this is what our equation will look like. Now we need to separate this. We can see that here we have a number, and it's being multiplied by a number. And then this is being multiplied by another number. And this looks like the second Demorgan theorem. So when we write this out, we are going to say that our f naught is equal to, and then we're going to have the naught over our first number, so a plus b naught plus c. Remember, the pluses are ors. And then this is going to have a plus, and the plus, again, is an or. So we have an or, and then we have a naught, and then we have the next part, which is a naught, b naught, plus c. And then we have a plus, cover naught, a plus b naught, and then a c naught in here. So this is going to be our new equation. So this will be our new equation. And from here, what we're going to do is, well, we see that we have a naught over all of these. And since we have a naught over all of these, what we're going to need to do is separate this. So looking at this first part, we have this a plus b naught plus c all under a naught. And since we have these pluses right here, well, this looks like the first Demorgan theorem. So we can rewrite it as such. We are going to have that our f naught is equal to, and then we have our a naught times, and then that means an and, right here, times an and. We have our b naught naught, and then our c naught. We're going to look at the next one now, which is this part right here. We're going to look at this next part. We have to look at all of this, and well, we have some number right here plus some number right here. So when we write this out, we are going to have the plus, which is on the outside. We have our first number. It's going to be this not a, not b, and then we have this not c. And now, knowing this, we can write out the next part, which is this right here. And I'm going to do it in red just for consistency. So for this one, we have some number plus another number underneath a naught. This is our first Demorgan, so we're going to write it out as a naught, and then we have a times in the middle, and then we have our b naught, c naught, and this is all under a naught. So this is our new equation, and now we can focus on this part. So we'll rewrite it, and we will write it a little bit simpler. So we have the complement of our f is equal to our a naught times the b, because a naught over a naught is just a regular, and then we have our c naught. So that's that part done. Now looking at the part that we underlined, we have a number times a number underneath our naught, so this is the second Demorgan theorem. That means we're going to have our a naught naught plus our b naught naught, and then we have our c being multiplied into all of this, and this is a c naught. We're next going to have a plus. Looking at this next part, well, we have this part right here. This is the second Demorgan theorem. We're going to have our a naught on the outside, and then inside of our parenthesis, we are going to have our b naught naught plus our c naught naught end parenthesis. And so when we write this out, we're going to have our a naught, b, c naught plus our a plus b, and then inside of here, we are going to have, and then outside of here, we're going to have our c naught plus our a naught, and then inside of here, we're going to have our b plus c. And so that is the equation for our part D, and that is how you would go about solving for part D. And you can use kind of that formula to solve for any of complements, even if they don't look like this.
Could never meet you in your little mini